I will present you to my applied electromagnetics project, which is the examination of rectangular cavity resonator. Rectangular cavity resonator design will be based upon my selection of cutoff frequency. My selection of cutoff frequency is 1 gigahertz. In that frequency, uh, I will try to propagate TE 101 mode, and by using this formula I can find the dimensions of my cavity, and after I use this formula, my dimensions is like in x dimension, in the x axis. My length will be about 25 centimeter, and 10 centimeter on y-axis, and 18 centimeter on the z-axis. And the structure of my cavity resonator is like this. I have coated the cartoon with aluminum foil, and I use aluminum tapes. The reason for that is to make dispersion as perfect as possible, dispersion of waves as perfect as possible, because if I use normal rubber bands, they are non-conductive, and they will prevent the surface current on the cavity, and which also affects the dispersion of waves, like propagation of electromagnetic waves inside the cavity. To excite my cavity, I have used monopole antenna, which is located in here. And as you can see, I have also connected some aluminum and copper tapes of antenna to the my cavity, and the location of my antenna is selected according to the impedance that I see on the cavity. I have used many locations, but as best I can get is that location that I showed you before, because in that location I got 35 ohm of resistance, and which is the closest points I could get to 50 ohm, where the 50 ohm is the impedance of signal generator. If I match this resistance with the signal generator resistance, I will decrease I will decrease the attenuation in my cavity, and it will be matched circuit, and we can easily see the behavior of cavity without these effects. But I could get as close to 35, and after that I have tried to find my selection of cutoff frequency. Like, I want to see the behavior of the cavity resonator according to my cutoff frequency selection. For that, I have implemented this. I have examined this behavior. This graph shows you the reflection coefficient, and in the reflection coefficient of this graph, like in the cutoff frequency, as you can see, in cutoff frequency, this H will be equal to this part, and this makes the gamma value, which is the propagation constant value, as 0, and this means that there will be no propagation at cutoff frequency. So if there is no propagation, reflection coefficient will be 0, because if there is no wave to propagate, there will be no waves to reflect. So as you can see, there is a dramatical drop in here. As theoretically it should be 0, like the drop should be like minus infinite, but as you can see, since it is not theoretically perfect, it is an experiment, it is about minus 10 dB, which is which is also our aim as in the project. And there are other points I want to talk about in here, is like formal frequencies. Like, there is also drop in formal frequencies. This will be the reason of this is again gamma value. Gamma value in that area, in that range, gamma value is real, and since it is real, there is attenuation, and because of the attenuation, there is this drop, and in that range you can see it is perfect, like normal line. uh, in that range gamma is imaginary, so there is no attenuation. This is the area that we want to work. There is also a drop in here. This is for the another modes of the cavity resonator. And after that I implemented my second antenna, and I want to, like, I give my signal from here and I want to observe my signal from there, and I want to see the loss amount at the cutoff frequency. Like, if it is not in the cutoff frequency, I would observe exactly the same signal, but in the cutoff frequency there is a change, and I will show you this change. Like, this is my input signal. As you can see, it is 1.44 44 volts, and it is the frequency of this 1 gigahertz. It arranged like that, and the signal seen on the second antenna is this, and you can see it's about 400 millivolts, and this, as you can see, there is a loss about like more than 10 dB, and this is our aim. The behavior of the cavity resonator is examined, and that's all. Thanks for your listening.